Hello friends, this video on complex number part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched complex number part 1. Let's understand power of I. I we know is root of minus 1. So I square is equal to root of minus 1 whole square, and that becomes minus 1. When you say I cube, that is nothing but I into I square. And I square is equal to minus 1, so it becomes minus I. When you say I4 is nothing but I square whole square, and I square is equal to minus 1, so minus 1 square, that is equal to 1. So we have seen I is equal to root of minus 1, I square is equal to minus 1, I cube is equal to minus I, and I4 is equal to 1. Similarly, when you say I5, now I5 will be I4 into I, correct? And I4 is always 1. So we'll say 1 into I, that becomes I. When you say I6 will be I4 into I square, and that will become 1 into I square. So it will become I square. So what we have to do, if we have got I to the power n, so what we do, we will find first till 4, whatever the factor comes. So let's suppose this guy is I to the power 4n, this guy will always become 1. Because I to the power 4 is 1. Now we'll talk about identities. When you say z1 plus z2 whole square, it becomes z1 square plus z2 square plus 2z1 z2. This is similar to the normal formula we have, a plus b whole square is equal to a square plus b square plus 2ab. Similarly for z1 minus z2 whole square, it is z1 square plus z2 square minus 2z1 z2. It is like a normal real number. z1 plus z2 whole cube is equal to z1 cube plus z2 cube plus 3z1 z2 square plus 3z1 square z2. Similarly for z1 minus z2 whole cube, same formula which we have for normal numbers, and z1 square minus z2 square is equal to z1 plus z2 into z1 minus z2. So we see that the formulas are same. In case of a square minus b square also, you have a plus b into a minus b, if you are taking a and b are normal real number. In case of z1 and z2 also, we have same formulas. So all the formulas are same. Now we will do some problem where we are supposed to express in the form of a plus ib. So if we have this number 5 minus 3i whole square, we have to express in the form of a plus ib. So 5 minus 3 whole square is equal to a square minus b square minus a square plus b square minus 2ab. Correct? So what you get is 25 minus 9, because 3i square is minus 9, minus 30i, and this is nothing but 16 minus 30i, and this is nothing but a plus ib form, where a is equal to 16 and b is equal to minus 30. Modulus of a complex number. Let there be a complex number z is equal to a plus ib. Modulus of the complex number z is denoted by z enclosed within mod, and this is said to be root of a square plus b square. That means we can say mod z is equal to root of a square plus b square. Please note that for a complex number a plus ib, the mod is root of a square plus. Let's take one example. Let's say z is equal to 3 plus 2i. In this case, z, that is mod z, is equal to root of 3 square plus 4 square. That is root of 9 plus 16 is equal to root of 25, and that is nothing but 5. Please note, mod of z is root of a square plus b square. Let's take one more example to solve our concept. We have to find the modulus of 3 minus 5i into 2 plus 4i. As we know that for z is equal to a plus bi, mod of z is equal to a square plus b square root. So first we have to convert this number into a plus ib form. Let's do that. 3 minus 5i into 2 plus 4i. This is equal to 3 into 2 is equal to 6, plus 3 into 4i is equal to 12i, minus 5 into 2i is equal to 10i, minus 20i square, and i square as we know is 1, so it will become 6 plus 20 plus 2i, that is 26 plus 2y. So z is equal to 26 plus 2y. Now when we are talking about mod of z, that is equal to root of a square plus b square. Here 26 is a and 2 is b, because this is of the form a plus bi. So this is equal to 26 square plus 2 square. 26 square is equal to 676. 26 square is equal to 676. 2 square is equal to 4. This is equal to root of 680, and this is the answer. Please note, mod of z is equal to root of a square plus b square, where z is equal to a plus bi. Now let me introduce you a new term called conjugate of a complex number. It is denoted by z with a sign here. The complex number a plus ib, or a complex number where z is equal to a plus ib, the conjugate is a minus ib. This is the conjugate. So if a plus ib is the number z, then z conjugate is equal to a minus ib. Also, when you multiply z into z conjugate, you get modulus of z. For example, z is equal to 2 plus, or we'll say a plus ib only, and z complement is equal to a minus ib. Z conjugate. You multiply this z into z conjugate, what you get? A plus ib into a minus ib. This is nothing but a square plus b square. We'll take some more example of conjugate of complex number. So this is the complex number, and we have to find the conjugate of this complex number. So before finding the conjugate of this complex number, we have to convert this number into a plus ib form. So let's multiply this and rationalize this. So first we'll multiply this. So 3 plus 5i will get 3 into 2 is 6, and plus 3 into 4i is equal to 12i, minus 5 into 2i is equal to 10i, minus 5 into 4 20i square, and this is whole divided by 1 plus 2i. So what you get is 20i square is minus, it becomes plus, so you get 26 plus 2i by 1 plus 2i. Now we'll rationalize this. So we'll divide and multiply by 1 minus 2i. So what we get here is a square plus b square, 1 plus 2 square, 1 plus 2 square is equal to 4. And here what we get, 26 into 1 is 26, minus 52i, 26 into 2i, plus 2i into 1, 2i, minus 4i square. So here what you get is 30 minus 50i by 5, and this is nothing but 6 minus 10i. So this is z, and when you want to find z conjugate, this will become 60 plus 10i, and this is our answer. Very simple. To find the conjugate, first convert the number into a plus ib form, and then find a minus. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more.